Hi there, grade 12s. Welcome to the analytical geometry lesson. So on this lesson, we're going to work on the equation of a circle and we'll explain everything that you need to know when it comes to analytical geometry grade 12. So if this is your first time watching our lessons, please make sure that you join the family, subscribe to the channel, and uh, you'll get a notification when we upload the next one. So let's start with the lesson. We're going to work on the equation of a circle. Right, so on this one, a circle, remember a circle, it's a set of points which, okay, let me just give you something like this. Let's say this is my circle. Okay, so on this circle, we're gonna have the center of the circle, and the center of the circle is on the origin. Okay, it's on the origin. This is your x. Let's say this is your y, and this is your y. So if you look at this circle, we know that the center, a line from center, a line drawn from center to the circumference, we call that line radius. So this will be my r, radius. And then now I can form what? A right angle triangle in that form, and say this is my x and this is my y. This is 90 degrees. So now let's refer to this diagram, and what will be the equation of the circle? We can find the equation of the circle using the Pythagorean theorem. I hope you are with me on that. Ne? So if you still remember the Pythagorean theorem, it says that r squared is equals to x squared plus y squared. Okay, so this will be the equation of the circle, which can also be written in the form of x squared plus y squared is equal to r squared. So this is the equation of the circle. So the equation of the circle, if we have the center as origin. Okay, so now what will happen if, let's say that if we have a center, let's say the center that we have, let's say we have a center A and B. Remember, when it's in this form, A and B is not the origin. What will be the equation of the second? So we're gonna say this is x. We minus the x value, right, which is A. This is squared. We add this to what? To y. We minus the b value squared, and everything should be equals to r squared. So you need to understand how to find the equation of the circle with center O, and you need to understand how to find the equation of a circle if we have the center with A and B. We'll definitely work on example, right? So let's do one example and see what we can learn from this example. Okay, so let's say we consider an example where we are given the radius of 5 units. Né? Let's say the radius of the circle is 5 units, right? And then we have a center of the circle, a center P, which has the coordinates 5 and -3. So if you look at this, you can see that the center is not the origin. Which equation should we use? So I want us to use this in this form. Can we please say this is my equation 1, right? And let's call this my equation 2. So now tell me, we have a radius with 5 units and a center P that has 5 and -3. So which one will be the equation that we need to use to find the equation of that circle? Is it equation 1 or equation 2? That's what you need to ask yourself. So now looking at this, it has the center A and B, where the value of A is 5 where the value of b, let's not call this x and y, né? So where the value of b is minus 3. So let's rewrite the equation down. The equation that we'll use is equation 2, x minus a squared plus y minus b. This squared is equals to r squared. Okay, so now what I'm gonna do from this point, I need to substitute. Remember, this is a, this is b. On the equation where there's a, we need to put 5. Let's go and substitute. So this will be x minus a, which is 5 squared, plus I'm going to have this as y minus into minus 3. Very important to put the minus 3 inside the bracket, and let's equate this to r. What is the radius? The radius is 5, so this will be 5 squared. I hope you understand the substitution. The most important thing is that if between a and b, one value there is negative, make sure that when you subtract it, you put it inside the bracket, and this will give us x minus 5. This is squared, and plus, now we need to multiply out of that bracket and say minus times minus is positive, so this will be y plus 3, and this is squared, it's equal to 5 squared, that's 25. So, ladies and gents, therefore, this is the equation of the second. I hope you understand how to find the equation of the second. So this will be the equation. This will be the equation of the second. Okay, so this is your equation of the second. Right. I hope everyone is happy about that. Let's work on more examples. But now, let's say that on this example, now we were determining the equation of the second. So now I want us to talk about what you learned in grade 10, which is completing the square. On completing the square, this is something that you need to understand to master analytical geometry. So let's say that we have 3x squared. Let's say you are given the equation of the second as 3x squared plus 6x plus 3y squared minus 12y minus 33, and let's say this is equal to 0. We need to determine, they'll ask you to take this information and determine the equation of the circle and the radius. So the question will say determine the equation of the circle and the radius. Okay, first thing first, remember the equation of the circle, it should be in the form of x minus b. X minus a. It should be in the form of x minus a squared plus y minus b squared is equals to r squared. We need to take the given equation and put it in that form. What should we do? The goal is to determine the equation of the circle in this form. Okay, and then we can do this by completing the square. Right. So when you complete the square, first thing first, we first ensure that the coefficient of x squared and what? The coefficient of x squared and y squared are 1. Okay, so that's what you need to first make sure. So if you are given we need x squared, let me write this down so that you can understand what I'm referring to. So we need the coefficient of x squared and y squared to be 1. Very important. That's the first thing we need to do. So if you look at the equation, I have 3x squared plus 6x plus 3y squared minus 12y minus 33. It's equal to 0. Today it's our lucky day because everything here is divisible by 3. So we can just divide everything by 3 to find to make the coefficient of x squared and y squared to be 1. So I'm just going to divide that term by 3, divide that by 3, divide that by 3, everything by 3. Okay, everything by 3. Therefore, the new equation, it's x squared, 3 goes into 6 times, plus 2x plus y squared minus 6y. 3 goes into 12 4 times, not 6 times, right? So this will be minus 4y minus 7. And this is equal to 0. So now, if you can look at this, we've managed to make the x squared to be what? The x squared and the y squared to have the coefficient of 1. Okay, so now I need you to place the constant on the other side of the equation. This 11, I need you to put it on the other side of the equation. Let's rewrite the equation and place the constant on the other side of the equation, which will be x squared plus 2x plus y squared minus 4y is equals to 11. Right, so this is what we have, and then now we can complete the square. If you still remember, how do we complete the square? We're gonna add the coefficient of b over 2 squared on both sides. Okay, let's start with I'm gonna start with this one, because if you can check, we have two variables. We need to first complete the square for the variable x, which will be what? It will be x squared plus 2x. So this will be x squared plus 2x. So what is b? B is the coefficient of what? B is the coefficient of x. The number that is in front of x, which is 2, we need to say we add that. It will be 2 over 2 and everything squared. Right? So I'm just going to leave the space and equate this to 11. But remember, what you do on the left-hand side, you also do on the right-hand side. So we also have to add the 2 over 2 on both sides. I hope you understand that part. I hope you are happy with that. So we need to do the same for the equation that has the variable y, this equation. So this will be plus y squared minus 4y. We add the variable is the coefficient of x or y. The variable of x this time it's minus 4. So I'm gonna advise you to take that with negative. I'll explain why. So this will be minus 4 over what? Over 2. Okay, minus 4 over 2 and everything squared. Then whatever that we add on the left hand side, we have to add it on the right hand side. Right. So now let's start with the first one. I'm just going to start working on the first one. So the first one, make sure that you work out with the bracket first. And let's do this. This is x squared plus 2x plus 2 over 2. That's 1. Leave it like this. Don't say 1 squared. Just leave it as 1 to the power 2. You only work there, whatever that we have, the fraction inside that bracket, we only work the fraction inside the bracket only. Okay, then this one will be plus y squared minus 4y plus the inside bracket is minus 2 and this is squared. So now one thing I don't want you to stress about now is the right hand side. The right hand side, you can just punch this on the calculator. 11 plus 1 plus 4. So this is what you'll get. So it will be 11 plus 1 plus 4 if you work out the bracket. But this side, I need you to leave the brackets like that. I need you to leave the brackets like that. And now this will make sense why I need you to leave the bracket. Let's start with this one. X squared 1 squared. Those are the difference of squares. We can write this as x minus or x plus 1 squared. I hope you understand. You just take the x and the 1, everything inside the bracket squared. Then that plus sign, this will be plus. You do the same. Y squared minus 2. So this will be, both of them, they are squared. So this will be y. You minus 2 and everything squared. Then this is equals to, you just punch 11 plus 1, that's 12 plus 4, that's 16. So you can see that the equation of we have the equation in its standard form. So since you have the equation in standard form, you can determine the radius. First thing first, what will be the center, the coordinates of the center? What will be the coordinates of the center? So the coordinate of the center will be that one, which will be negative, because remember it's x plus 1 is equal to 0. Therefore, you can say x is minus 1. I hope you understand why it's like that. Because if even if we're not equating to 0, let me show you where is that coming from. Guys, if it's 1, the equation would be minus 1. If it's minus 2, the equation, the y value will be what? Positive 2. Let me explain where is that coming from. Remember, if we substitute this equation to form the equation, we'll have x minus b. It's x minus a again. So this will be x minus a into minus 1. And this gives us what? This gives us x plus 1. So you understand where is the x plus 1 coming from. So the center will be negative 1 and positive 2. Same applies. Remember, this will be y minus b, close the bracket, squared. But when we substitute the 2, this will be y minus inside the bracket 2, which gives us what? Y minus 2. So that is the y minus 2. I hope you guys understand what I'm trying to explain here. But the best thing that you need to know, the best thing to play around this is for you to say, if you have positive 1, just know that the x value of the center will be minus 1. And if you have minus 2, just know that the y value of the center will be negative 2. I hope you are still with me on that. So now that you have the center, it will be easy for you to find the radius, because the radius, we just take the 16. We can say that r squared is equals to 16. Square both sides, the radius is always positive, which will give us r to be 4 units. And that's the radius. We have the center, we have the radius, and then now we can plot that on the graph and see what we get. Okay, we can plot that and try to draw the equation of the center. This is my x, this is my y, and the center is minus 1 and 2. So it will be somewhere there. So that is the center. So the center is minus 1 and 2. And then you can just draw your circle like that. Don't worry, I know it's not drawn to scale, but I'm just trying to give you the clue how the circle will look like. I hope you guys are having much fun there, because I'm also enjoying this on my side. So now let's work on another example. So now, on this one, let's say that we are given, okay, let's say that you are given x squared plus y squared minus 6x plus 2y plus 8. Let's say this is equal to 0, and we need to determine the center and the radius, okay? Determine the center and radius of the circle. Okay, so now first remember we need to write the equation in the form of x minus a squared plus y minus b squared is equals to r squared. And this means we need to complete the square. Let's go and complete the square. But now, before you complete the square, make sure that you group your equation like this. You group this one with that -6. Then you group that one with the 2y. Then you take the 8, you bring it to the other side. So what I'm trying to say, we'll rewrite this equation to be x squared minus 6x. Then I'm just going to leave a space. And then let's write this as 2. Okay. Y squared plus 2y. I'm going to leave another space and equate this to -8. So now I'm happy that the x squared already has the coefficient of 1. So I can just add what? The coefficient of b over 2 squared on both sides. So here the coefficient of b is -6. So I'm going to add -6 over 2, and this is squared. Then plus y squared plus 2y plus, we add for this one the coefficient of y, which is 2 over 2 squared. Remember, what we add on the left hand side, we also need to add it on the, whatever that you add on the left hand side, you need to add it on the right hand side. So this will be plus -6 over 2, and this is squared. We also add the 2 over 2, and this is squared. Nice. So remember to work the brackets first, and this will be plus -6 over 2, that's -3. I'm going to leave it as -3 inside the bracket, squared, plus y squared plus 2y, and plus 2 over 2, that's 1. I'm going to leave it at 1 squared, and this is equal to -8. The right hand side, we can solve the bracket because -6 over 2, that's -3. -3 squared. So we know that -3 squared, that's 9. Okay. So this will be plus 9 and plus 1. Right. Plus 9 plus 1. And if we add -8 with 9, we get 1. 1 plus 1, that's 2. Remember, the x and the -3, both of them are squared. We can just take the x and the -3 inside the bracket and everything squared. We apply the same this side. Both of them, the y squared and the 1, both of them are squared. We can write this in the form of y plus 1, everything squared. And this is equal to 2. So the equation of the circle, therefore the equation of the circle, it will be x minus 3 squared plus y plus 1, and this is squared, and it's equals to 2. Right. So what will be the center of the circle? Remember that to find the center, where the x is x minus 3, so inside the bracket of the center will have +3, and this one, since it's +1, it will be -1. Please keep that in mind to change the signs. So therefore the last part is finding the radius. We just say the r squared, it's equal to that 2, then you're going to square both sides. Therefore the radius is just √2. Then you leave it like that. And we can also plot it on the circle. Right. Okay, let's keep on working on more examples, and so that we can, let's say we have this example here. Okay. Right. So if I have a circle like this, let's say I have a circle, this is my x, this is my y. Let me first put my circle there. Okay, so this circle, let's put the radius somewhere there on the y-axis. Please pay attention, where's the radius on the y-axis, and let's put another point there, and then let's put another circle that's touch this point at one point. So we have 2 circles, and then this is circle K, and we can call this maybe circle B. So this B, let's say B is the center of the circle with 0 and 4. Okay, and then let's say that this point here, that point, let's say it's G with the coordinates 6 and 4. So this is what we have from the problem. And now the question says the circle B and K touch at point G. So this is where the two circles touch. Né? They touch at this point. This is where they touch at that point. The diameter of the circle B is 3 times. Okay, let me write this down. The diameter of the circle, the diameter of the circle B is 3 times what? This is 3 times as long as the diameter of the circle K. Please make sure that you understand what is this statement saying. We'll definitely work on that. Circle K. So we are given that the diameter, remember the diameter, it's a line drawn from the circumference and it passes through the center to another point on the circumference. And they say that for B, the diameter of circle B, it's 3 times long as the diameter of circle K. We'll talk about that. And the question says you must find the equation of circle K. So we need to use this statement, try to analyze the statement and find the equation of what? And find the equation of circle K. So we are looking for the circle K. Guys, this is very, very easy. Only if you understand what is the statement saying and if you understand the drawing. Okay. So now, first we need to take note of the radii of circle K and B. Okay. Let's take the note on radii. If the diameter of the circle B is 3 times long as the diameter of circle K, what I need you to note is that the radius of that RK, of the circle of RK, it will be 3 times of what? The radius of that one of B. Please, I need you to pause the lesson, make sure that this thing makes sense. You understand what I'm trying to do here. So what I'm saying is that, remember the radius is the same. So what I'm trying to say is that this line here, if this is my radius and this is my center. So I'm saying that this one, this is my R, the radius of B. So I'm saying that the radius of B will be 3 times what? It will be 3 times the radius of RK. The radius of K. I hope you understand what I'm trying to do. So this is the trick in this question. If you understand the trick, then you are good to go. Because the radius, remember, they said the diameter is 3 times. So this also applies to radius. The radius of RK will be 3 times the one of B. Then now, therefore, what is the radius of K? Because we are looking for the circle K. So if I divide both sides by 3, divide both sides by 3, this gives me what? The radius of that circle K to be 1 over 3 of RB. Okay, do we know what is the radius of B? Do we know that? Yes, we definitely know the radius of RB. Let me explain this. If this is the center and this is another point on the circumference, look at this. If we look at this is my X, this is the Y coordinate, this is the X, this is the Y coordinate. Look at this. Both of them, they have the same Y coordinate. This tells you that this is the horizontal line. This line is parallel to that. So since they are parallel, both of them, they have the same Y value. This tells you that the distance from B to T, it's 6 units. That is the radius. It will be 6 units since it's a horizontal line. So it will be 6 units. Where there's RB, we can substitute my RB, the radius, as 6 units. You see, this will be the radius, it will be of B, it's equal to 6. Now we can use that to find the radius of K. And when we have the radius of K, everything will be much easy for us to determine the equation of that. So the R of K, it's 1 over 3 times 6. Therefore, this gives us the R of K to be 1. 6 over 3, that's equals to 2. So this will be 2 units. So the radius of the circle that we are looking for is 2 units. This makes sense, right? Look at this. I have a line from this to that one. So what we are saying is that the distance here is 6, right? If the distance here is 6, this one will be 2. So we know that 2 is 3 times 6. So 2 goes into 6 3 times. You understand? Right. So from this information, we can extend the line of the 2 units. Let's work on that now. Okay. So now I'm going to redraw my graph. Even if we don't redraw it, I think. Okay. Let me redraw this. Okay. I'm just gonna redraw the problem here, and then I'm just gonna redraw this. Remember, this is my okay, this is X, this is Y, and this is my okay, let me quickly redraw that drawing. We have a center there and the point of contact of the small circle. Okay, we can see that, and then we know that this one, this is my B, which is 0 and 4, and then this was my point, this was my point G, which we said it's 6 and 4. I hope you understand that part. So we can extend this radius, the line from this part to form the radius, okay, and call this the center of K. What will be the center? We don't know what is X, but we definitely know the Y values because all these 3 points are horizontal to the X-axis, which they will have the same Y coordinates, okay? So the most important thing is to understand that the Y is 4 and what will be X. You just have to understand what will be X. We just calculated the radius of the small circle to be 2 units, and we know that the radius of the big one is 6. I hope you understand that part. So this gives us the center of the circle, of the small circle, to be what? It will be 6 plus 2. So we already have the 4, and then now we need to find that X. So X will be from this point here. I hope this will make sense. From this point here all the way to that point, which is 6 plus 2. So the X of K will be 6 plus 2, which is 8. Okay, so the center K will have the coordinates 8 and 1. It will have the coordinates 8 and 4, which makes it easy for us to find the equation of that circle. I hope you understand what I did then. If you don't understand, you are more than welcome to pause the lesson, work on it again. So when it's like this, I can just substitute and say this is X minus 8, which is what? 8, we said we need to put negative 8, and then plus Y minus 4, it's equal to radius is 2. So this will be 2 squared, which is 4. So the center of circle K will be X minus 8 into Y minus plus Y minus 4 squared. It's equals to 4. This is the center of the circle. I hope you understand that partner. I hope you had so much fun working on that one. Right. So on the next part of this lesson, it's where we're going to discuss about the tangent to a circle, which also plays an important role when it comes to tangent to a circle, exam questions. Okay, so let's say that I have a circle like this, and now this is my center A. Remember that a tangent is a line that touches the circle at one point. So if this is A, C, B, D, so this is 90 degrees. The reason we are going through this is because there's something that I need to explain to you and make sure that you still understand the concept. The gradient of AB, when we multiply that with the gradient of CD, we need to find the answers -1. So the tangent is perpendicular to the radius. So this will tell us that the product of the tangent and the radius of the circle is -1. Right. So when determining the equation of the circle, there are certain steps which we can take. Okay. So the steps for determining the equation of a tangent to a circle. Number one, make sure that you determine the coordinates of the center. You need to have the center. You need to determine the coordinates of center. Okay, that's very important. Number two, you need to calculate the gradient. Okay, right, calculate the gradient. That's the second step. Number three, you're gonna need to determine, so this is the gradient of what? Between the center of the circle and the point of intersection. This is between the center and point of intersection. Then now, when you have that, you need to use the M1 times the M2 formula to find the gradient of what? The gradient of the tangent. Okay. Then number four, you're gonna sub in the gradient in the formula y is equal to mx plus c. Then five, you're gonna sub in any value, any coordinates. You sub in the coordinates of the point of intersection. The coordinates of point of intersection. Guys, I'm very sorry about too much notes, but let's work on an example. Let's work on an example so that I know, so that these steps can make sense. So if I have something like this, okay, so let's say that we have x squared plus y squared is equal to 30. This is the circle. This is the circle, and we need to determine the equation. So we need to determine the equation of tangent of the circle at point, let's say P of -3 and 4. Okay. Okay, so let's look at this. We know that -3 and 4, -3 and 4, it's somewhere here. You see? Okay, so this will be my equation. So this is the point of -3 and 4. That's the point. Minus 3 and 4. Okay, so you know what I'm gonna do? Remember, first thing first, we need to determine the coordinate of the circle, and which is the origin. How do we know that this is the origin? By looking at the given equation, the x squared plus y squared. So this tells us that the origin is at 0. So the center of the circle, it will be 0 and 0. I hope you're still with me on that. That's the center. So now we need to calculate the gradient between the center and the point of intersection. So we need to find the gradient of OP. Okay, we need to find the gradient of OP using the formula that says change in y over the change in x. Right? So if I write the circle down, this is P, it will be minus 3 and 4. So which one is your x, which one is your y? That's what you need to identify. My x1, y1, this will be my x2, y2. So when I substitute, we're going to get my y2 to be 4 minus y1, which is 0, over x2 minus 3 and minus 0. And this gives us 4 over 3, which is negative. So the gradient of OP, therefore, the gradient of that OP is equals to what? Minus 4 over 3. Okay, so that is the gradient of OP. So remember, when you have the gradient, we said you determine the gradient of the center and the point of intersection, then we need to use this formula to find the gradient of the tangent. That's what we need to do next. So we're going to say that if we multiply these two gradients, what do we get? The gradient of OP multiplied by the gradient of the tangent, and this must be 1. OP is minus 3 over 4 times the gradient of the tangent, which is what we are looking for. Remember, now we need to make that a tan subject of the formula. So it's like saying this will be the reciprocal of that 3 over 4 without a sign. So it's just saying the tan is 4 over 3 without a sign, because we divide by minus 3 over 4. Right. So we have the gradient of the tangent. You can just go back and substitute this on the straight line equation, okay? Because y is equals to mx plus c. The gradient, now we know that the gradient of tangent is 4 over 3 plus c. Then you need to substitute the point of what? We need to substitute that point of intersection, the one that is given there, which is P, minus 3 and 4. So we need to substitute that and see what will be the equation of the tangent. So we're going to substitute minus 3 and 4, which makes this my x and this my y. So when I put y, this will be 4. It's equals to 4 over 3 into minus 3 plus c. The 3 and the 3 cancels, we are left with, what is this? Is this 4 over 3? I think, okay, if I go back here, we said that the gradient, we got the gradient to be 4 over 3. And then now we made a mistake here by substituting this as 3 over 4 instead of 4 over 3. So this will be 4 over 3, which makes our gradient to be 3 over 4. Okay? Let's restart the process. Let's first substitute the correct one. So this will be 3 over 4. Okay? So where that's why we put 4, this is 3 over 4 into x, it's minus 3 plus c. So this is the same as saying 4, it's minus 9 over 4 plus c. Then we need to bring this thing on the other side. We need to write this as 4 plus 9 over 4 is equal to C. We know that the top part will be 4 times 4, which is 4 times 4, that's 16. And then C will be equals to 16 plus 9, that's 25. You can use calculator if you have it. You can use the calculator on your side. So the value of C is 25 over 4. Therefore, what is the equation of the tangent? It's y is equals to 3 over 4x plus that C, which is 25 over 4. Now, okay. So now that you understand how to find the equation of a tangent, there's something very important. Now, how will we be able to prove if a straight line is a tangent to a secant if we have given both equations? So you are given both equations, right? You are given both equations and you need to prove if a straight line is a tangent to a secant. That's what we need to work on now. Okay, so if we have been given both equations, let's consider the following example. Let's say we have the equation of a secant. Okay, so it's given as x squared plus y squared is equal to 10. Then the question says determine whether the line with the equation y is equals to 3x plus 10 is a tangent to a secant. Okay, so a tangent to a secant or not. So look at what we are given. We have the equation of the secant and the equation of the tangent. We need of the straight line. So we need to check if that y is equal to 3x plus 10 is the equation to a secant or what. Is that a tangent or what? So first thing first that I need you to do, remember a tangent. I'm just going to put this here now. I need you to always remember this. So in order for you to be able to do the proof, you need to remember that a tangent, it intersects, it's gonna intersect what? A circle at one point. So in order for you to prove, we first have to check in on these two equations. The first equation is given as x squared plus y squared is equal to 10. I'm going to call this my equation 1. And then we have the equation 2. Okay, let's start with the straight line, because I think it's easy to work with the straight line because we can make something already. Y is the subject of the formula. Okay, so y is equals to 3x plus 10, and I'll call this my equation 1. And then we are given x squared plus y squared is equals to 10. That's my equation 2. So you know what you're gonna do. We need to solve this using simultaneous equation to determine how many solutions we get. This will tell us whether it's a straight line or a tangent. So if we get 2 solutions, that's not a tangent. But if we get 1 solution, it's a tangent. Okay. So now already we know what is y. Y is 3x plus 10. Where there's y on this equation, we're going to sub equation 1 into equation 2. So this will be x squared plus, where there's y, we can put 3x plus 10, and this is squared. Let's equate that to 10. This is equals to 10. Okay, so if we work out this thing, this is x squared plus, let's expand the brackets, it's equals to 10. This will be 3x plus 10, 3x plus 10. Multiply out of the brackets, this will give us 3x times 3x, that's 9x squared. And then 3x times 10, that's 30x. And then 10 times 3x, it's also 30x. Then 10 times 10, that's 100, which is equals to 10. Then these are the like terms, which I'm going to add the 2 to get 10x squared. And these are also the like terms. This will give us plus 60x. I have 100. The 10 comes this side to be negative 10. This gives us plus 90. It's equal to 0. Then now, can we divide everything by 10? Yes. So this will give me x squared plus 10 goes into 60 6 times, and 10 goes into 99 times. This is 0. Therefore, we can just factorize this. We can factorize this and see what we get. So when we factorize this, this is x, and then we have 9 there. What is 9? This will be 3 and 3. Both of them are positive. Therefore, this gives us only one solution, which is x is minus 3. We only have one solution, okay? So now, since we have one solution, we can say that we have one solution. Therefore, we can conclude means that the straight line only touches the circle at one point, okay? And if we had maybe two solutions, x is minus 3, x is 5, then you can say no. Since we have two solutions, then it can be a tangent. So this tells you that therefore this equation, the given equation, proves that a straight line, this equation is a tangent. Therefore that equation is a tangent because we have one solution. So let's try and summarize all this information that we just worked on now. So in conclusion, the first one, when we talk about one solution, it's where we have the graph, right? So you can see that this one is one solution, okay? And then if I have something like this, and this is a straight line, you see, it touches the graph at 2 points, so this will be two solutions. So this one is not a tangent if we get two solutions. And the last one, it's if you have a circle like this and this one, there's no solution because it does not even touch the graph. So one or two solution, it's indicated that the line intersect with the circle. No solution indicated that does not intersect with the circle. For example, if they ask you to prove that the graph does not intersect, you should solve and your answer should be no solution. Okay, we can also do a practice problems using the nature of the roots. We can also apply this on the nature of the roots. Let's do an example that has to do with nature of the roots. Let's say that you have the equation of a circle, and it's given as x minus 5 squared, okay? And we say this is plus y squared. Let's equate this to 36. So, and the equation of a straight line, okay? The equation of a circle, the equation of straight line. It is not given that this is a tangent, they just say straight line. It's equals to y, it's equals to 3x plus k. And then now the question says for which values of k will the straight line be a tangent to that circle. I need you to be very smart on this question. I need you to be very smart. Look at this. Already we know that y is equal to 3x plus k. Because I see that k, I can say that this has to do with what? This has to do with nature of the root. But remember, we are given two equations, and the first one is x minus 5 squared plus y squared. This is 36. Let's call this equation 1, and then let's say y is equals to 3x plus k. Let's call this equation 2. Okay, so I can solve this via equation, because via simultaneous equation, because already I know what is my y. So this will be x minus 5. We just have to sub in equation 2 into equation 1. So where there's y, we need to put 3x plus k. So this will be squared plus 3x plus k squared, which is equal to 36. Then we just have to solve that problem. Let's start with the first one. Let's expand the bracket. X minus 5 plus, let's also expand this side, 3x plus k, 3x plus k. You'll see where is this going. This is equal to 36. Nice. So multiply out the bracket, add the like terms, we get x squared plus 10x. Okay, it's negative 10x, then 5 times 5, that's positive 25, plus we do the same 3x and 3x, that will give us 9x squared, 3x and k, that will give us 3 times k, that is 3xk plus 3xk, which is plus 6xk. I need you to pause in the lesson and try to multiply out this and see what you get. This is equal to 36. We have the like terms that we need to add. And looking at this, I have x squared and 9x squared, which gives us 10x squared. We have, okay, I think it's 10x squared. And then let's group the 10x with the 6xk. So this will be minus 10x, or let's start with the 6x. Okay, let's start with the 6x because it's the one that is positive. So I'm grouping this now. Minus, okay, plus 6xk plus, okay, minus 10. This will make sense now. Why am I grouping the two? Okay, so I'll definitely explain that. Minus 10x and the 25. What will happen with the 25? The 25, this will be 25 minus 36, because the 36 will go to the other side, okay? The 36, and then we need to group that with k squared plus k squared. So what do we get there? So 25 minus 36. When you say 25 minus 36, that's minus 11. So it's the same as saying this is k squared minus 11. So I'm going to group this with plus k squared minus 11. This is equal to 0. So now, if we go back to the question said for which values of k will the straight line be what? The straight line be a tangent to a circle. And we say that if it is a tangent to a circle, we only need one root. Okay, so if we need one root according to the according to the discriminant, for us to get one root, the discriminant must be equal to 0. The discriminant must be equal to 0. I hope you are with me on that. So now we need to put this in the form of ax squared plus bx plus c. So this is 10x squared plus, we need to take x out as a common factor. I'm left with 6k minus 10x. So now you understand why I wanted to group these two. And this one, both of them, they don't have the coefficient of x. So this will make them to be the value of c. So this will be plus k squared minus 11. Remember, a is the coefficient of what? A is the coefficient of x squared. This will be my b, which is the coefficient of x. And this is the constant value c. Then the discriminant it's equals to b squared minus 4ac. I hope you understand what is going on this problem. So now we know what is b, we know what is a, we can just substitute. So the value of b is 6k minus 10 squared minus 4 into the value of a, which is 10, and the value of c, which is k squared minus 11. You see, we have much work to do. First thing first, we need to expand the brackets this side. This will be 6k minus 10 into 6k minus 10 minus 4 times 10, that's 40, into k squared minus 11, and then 6 times 6, that's 36 k squared. 6 times minus 10, that's minus 60, minus 60, which gives us minus 120k, and then plus 10 times 10, negative 10 times negative 10, that's positive 100. Multiply out the bracket with 40, that's negative 40k squared, plus 40 times 11, that's minus, positive 440. This is equal to 0. Right. So from this, let's check if we have any other like terms. 36 minus 40k squared gives us minus 4k squared. Then I still have minus 120k, 100 plus 440, that gives us 540. This is 0. Can we divide everything by 4? Yes. By minus 4, this will be k squared plus minus 4 goes into 120 30 times. And then 540. What is 540 divided by 4? It gives us, we are dividing by negative, which will make this to be minus 135. And this is 0. Can we factorize this? Nope. But we can use the quadratic formula, okay? So this is in the form of ax squared plus bx plus c. The value of a, it's 1. The value of b, it's 30. C, it's minus 135. Right. So if we keep on working on this, k, it's equals to minus b plus or minus the root of b squared minus 4ac and everything divided by 2a. So k will be equals to minus 30 plus or minus 30 squared minus 4 into the value of a. What is the value of a? It's 1, and the value of c is minus 135. And everything divided by 2 into 1. Therefore, what is k equals to? When you punch that on the calculator, what is the value of k? Right, let me try to punch in this on my calculator and see what we get. Okay, this is minus 30 plus the root of that 30 squared minus 4 into a, which is 1, minus 135 over 2 into 1, which is just 2. And this gives us 3.97. And if we change the positive there to negative, what do we get? 3.97 and minus 33.97. So those are the values of k. So k is equals to 3.97, or k is equals to negative 33.97. And ladies and gents, that's how you definitely work on the problem. The problem set for which values of k will the straight line be a tangent to a circle. So in order for this to be a tangent of a circle, k must be 3.97 or k must be negative 33.97. You just have to go through everything that we did on the steps. First thing first, have equation 1 and equation 2, then make one variable subject of the formula, substitute that on the other equation, and try to put this in quadratic form so that you can use the discriminant. For one root, the discriminant must be equals to 0. Then you sub in your values, and this is what you get. Right. So now that you understand this, there are some of the things that we can definitely work on, which is the last part of this, and we'll do it on the upcoming lessons, which is circles that intersect. Okay, the circles that intersect. We'll definitely talk about that. But for this is where we're gonna stop for the lesson. And thank you very much for sitting in on the lesson. If this is your first time watching our lessons, please make sure that you hit that subscription button so that you don't miss the next lesson.